All right, so now we're looking at conditional probability, exercise 8D. Our learning intention today is to understand conditional probability and to be able to determine it using a Venn diagram or a two-way table. And so to activate our prior knowledge here, let's quickly describe what union and intersection mean, what the symbols are, and what the addition rule is. So I'll give you a moment just to think about those ones. Hit pause, write them down. All right, so union means or in a simple way. Or on a Venn diagram, it would mean everything in both options. So it's either in set A or in set B, both count. Intersection means and. So it has to be both. So it's this little section in the middle. They're symbols. I hope you're getting familiar with these ones now. You've got union and intersection. And the addition rule is the probability of A union B equals the probability of A plus the probability of B. And I reckon you guys are knowing by now that we also got to subtract the intersection, because of course if we add the probability of A with the probability of B, we'll double count that middle bit, so we've got to subtract it just to make sure. So now let's look at what our fresh stuff is for today. Conditional probability. So the definition of conditional probability is the probability of another event occurring given another event has preceded it. So it could be, the number that someone's rolled on a die is bigger than 3. So what's the probability of rolling a 5? Say you've already flipped the tail on your first flip. What is the probability of then getting another tail? It could be, say, say you're trying to guess what suit a card is, but they've already told you it's a red card. So it's going to increase your chances of getting it right. So this is how it's denoted. The probability of A given B, this vertical line here means given, equals the probability of A intersect B, and it's just out of the probability of B because we already know that B's occurred. So just take note of the formula here, how it works. B goes on the denominator, and that's the second one listed. That's given. And I'll show you why in this next slide. So the probability of A, you can see here, it's this section. Now, probability of A given B. So now we know B's already occurred. So we're just looking in this section of the Venn diagram here. Now, the probability of A occurring is going to be just the intersection out of B. So hopefully that helps you understand why B's in the denominator. Now, here we've got, again, in the two-way table, given B. So we're looking at this part here. Now, the probability of A, given we already know we're in this B section, is going to be just this dark box here, A given B. So now let's have a look at some worked examples on the whiteboard. I'll end this. Now, if you're feeling confident, feel free to give these ones a try on your own. Give these ones a try on your own and jump through and check your answers correct. I'm going to go through the answers now. So if you're not sure, then by all means listen in. So now we want to find the probability of A. So the probability of A is going to be equal to everything in A. So it's going to be 21 plus 14 out of our total. So 21 plus 14 plus 27 plus 28. So let's figure out what the total of that is. 21 plus 14 plus 27 plus 28 equals 35 out of 90. I can see straight away we've got a common factor here. So let's divide that into a fraction. 7 out of 18. All right, probability of A intersect B. That is talking about our intersection. So the probability of A intersect B is equal to 14, our intersection, out of 90. And again, I can see I've got two even numbers here, so let's simplify that fraction. 7 out of 45, common factor of 2. Next one, let's use what we've learned about probability of A given B. So now what this is saying is we already know that we've got B. What's now the probability that we'll get A? So this will be 14. So actually, let me go through the formula. So it's probability of A intersects B out of the probability of B, which is 14. 14 plus 27. 14 out of 41. Now let's go the other way, probability of B given A. So now we're saying we already know we've got A, so we're in this section here. Then what's the probability that we've got B? So this time it's probability of A intersects B out of the probability of A. So this time it'll be A intersects B, 14 out of 21 plus 14, 35. Common factor of 7, 2/5. All right, now let's try a worded problem. We have a school of 26 fish kept in a tank to monitor their health. They are chosen one by one to undergo a closer inspection of these fish. 9 have a white tail, 12 have a blue tail, 7 have both blue and white in their tail. So feel free to give this a shot on your own and then jump through to the answers at the end to check to see if you got it right. If you're not sure how to get started, then let's go through how to do this. So we've got a two-way table. So let's call this A and A dash. A is the fish has a white tail. B and B dash. B is that it has a blue tail. And figure out what we got going on here. So 9 have a white tail. And A is the fish has a white tail. So that means we've got a total of 9 here. 12 have a blue tail. So that means we've got 12 fish here that have a blue tail. 7 have both blue and white. So we're going to chuck the 7 in here. We also know there's 26 fish in total. Now let's fill in the blanks. So 7 plus 5, that's going to give me 12. 7 plus 2 gives 9. 9 plus 17, that'll give me 26. And then 12 plus 14 gives 26. And then we've got another 12 here. And it looks like everything adds up. So we know we haven't made any mistakes. Now we've got to interpret this information. Find the probability that a fish with a blue tail is chosen. So now we got the probability of getting a blue. That's going to be 12 from our blue in total is here out of 26. I can see we've got even numbers here, so let's simplify that fraction. 6 out of 13. Now we want to find the probability that a fish with a white tail is chosen, given, or whenever we see given, we know that we're talking about conditional probability. It has blue in its tail. So now we know given that it has blue in its tail, we know that we're talking about this section here. So given we know it's blue, how many have white? So you can see that there would be 7 out of 12 blue ones that are also white. We can also use our conditional probability formula. Probability of this time has a white tail, so that is A given B. Probability of A given B equals probability of A intersect B out of probability of B. So at A intersects B, we got 7 out of 12. Now the questions you're going to work on today, well, once we get back into class and we work on these, here you are. Best of luck. I'll see you in class.